Suppose you have hundreds of legal documents or thousands of support tickets, and each one needs one or more labels. You could ask an LLM to read every document and return a JSON. But what if I told you there's a faster, more predictable way to do this without paying for completion tokens? This is the cookbook for you. It's going to show you how to fine-tune the LFM2.5 encoder for multi-label classification in a single forward pass. So we're going to clone the cookbook and we're going to go to examples, LFM encoder classification. So this is the folder we're going to be working with. You're going to have all the code that you need in there. So speaking of code, let's look at the code. In here, you have several files. So once you are on the terminal, make sure that you are in the correct folder. You have switched not only to the cookbook, but to the specific folder that has this example. And in here, you have several files. The first one is the README file. It's going to give you all the instructions to be able to run this on your own and to also modify it for your own use case. In here, I have two examples. One is with a synthetic dataset and the other one is with a dataset coming from Hugging Face. So the first thing I want to show you is the train.py file. That's the most important one. Basically in here, we are taking the backbone of the encoder and let me show you. We are adding a linear layer with the number of classes that we're gonna predict. This is coming from the configuration file, so you can create your own. Here I put an example YAML file, so you can modify it for your own use case. So you specify which model do you want to use, whether you want to use the 350 million. In here, you determine what are the paths to those documents. So in this case, here I have a sample data set. This is a synthetic data set with train, validation, and test. They look like this. So you might be wondering, why are we using an encoder for this specific case? So when you're fine-tuning for a classification task, an encoder gives you several advantages. You don't have a decoding loop. You produce every label score in just one forward pass. There's no prompt formatting to maintain. There's no generated response to parse or repair. And the output is simply a probability for each known label. That makes the behavior easier to benchmark, threshold, and run repeatedly in high volume pipelines. The other advantage, which is the second example I have in here, is with the dataset coming directly from Hugging Face. So I'm using this dataset that is an European Court of Human Rights case. Here are each one of the labels, and these documents are quite big. However, the Liquid Foundation Model 2.5 encoder has a long context window. To be more precise, it supports 8,192 tokens and it uses a hybrid architecture. So its cost grows more gently as the input gets longer, especially on CPU. And same thing here, we have the different hyperparameters we used for this task. And last but not least, you have the predict.py file, so you can make the predictions. So here in the README, as I mentioned, you have the commands that you need to be able to run these tasks. So let's get to it. So UV sync to make sure that we have all the dependencies that we need. UV run train.py -- config. Here you pass it the configuration YAML file that you want. In this case, I'm going to use the config YAML as it comes. -- evaluate test, just to be able to get performance metrics on the test data set. So now we're going to let this run. And now that that has run, let's clear our terminal. And now let's run a prediction. So UV run predict.py with the configuration YAML file and the support ticket. So in this case, it says, I do not recognize the charge for a canceled subscription. The courier accepted the parcel, but the courier returned my package. And it correctly classified this as a shipping problem, and we can see the specific probabilities here. So as I mentioned, everything is in our cookbook on GitHub. You can clone this repo, get started today. And if you have any questions, join us on our Discord community.